In this video, I will be explaining the concept of the chain rule and showing an example of how you can use it. The chain rule is used to find the derivative of a composition of functions. So you want to find d dx of f composed with g, for example. Another way you could write this is d dx of f of g of x, with g of x being in the parentheses following the f. So this is, a composition of functions is when you have a function within another function. So the chain rule will tell you how you can handle finding the derivative of that by isolating the two functions and finding their derivatives separately. So the formula for chain rule says the derivative is found by taking the derivative of your outer function, so that would be f prime, evaluated at your inner function, so evaluated at g of x, multiplied by the derivative of your inner function, so that would be g prime of x. So chain rule says finding the derivative of f composed with g is the same as f prime evaluated at g times g prime. So when you are attacking a problem that requires the chain rule, you'll follow three simple steps. Number one is to identify your outer and inner functions. Once you've found what your functions are, step two will be to take their derivatives. Once you have identified and taken their derivatives, you will have f and g and f prime and g prime. So you'll have all the pieces you'll need. So step three is to plug those into the chain rule formula. Three easy steps. So now let's try an example. Let's say we're trying to take the derivative of e to the x squared, where x squared is the entire exponent on e. So by the chain rule, by the steps, first step will be to identify our outer function and our inner function. It's usually easier to identify the inner function first because it might be in parentheses or it will be slightly separate from the other pieces. So for our purposes, our inner function g of x is literally in parentheses. It's the exponent on e. It's going to be our x squared. That's our inner function. And now to find our outer function, we're going to look at all of the rest of the stuff that's left when you take out that g of x. So we're left with an e to the something. So that something will be whatever variable we assign to f. So to minimize confusion, I'm going to assign u. So it will be a function, f of u is our outer function, and it'll be e to the u. So that is step one completed. Now we move on to step two. We take each of their derivatives. F prime of u, the derivative of e to the u is going to remain e to the u because u is the variable. And to find the derivative of g prime of x equals, we'll use the exponent rule for the derivative, where you take the 2 down to the front and you drop the exponent on the x by 1. That'll give us 2. Technically, it's 2x to the 1, but we can just write it as 2x. So now we have the derivatives and we have our functions. Now all we have to do is plug the pieces into the chain rule formula. So our formula says we want f prime evaluated at g of x. So that will be taking this e to the u and putting g of x in for the u. So that first piece will become e to the g of x, which is x squared. So it'll be an e to the x squared in that first piece. And then the second piece is we simply multiply by g prime. Multiplied by our 2x. And there we have our final answer. The derivative of e to the x squared is e to the x squared times 2x. Thank you very much for your consideration.